We have a session from now till for about hour and 15 minutes. And I'm chairing this session. My name is Iona Silva-Fletcher. I'm one of the CP Fellows. What we would like to do is to divide the session into two half-an-hour slots and then have a joint discussion at the end, because we thought that the topics are kind of different, therefore it might be best to capture the questions at the end of each half-an-hour rather than waiting for the end, because we might forget what we wanted to ask from the first group of speakers. So to start off with, Marco and Matthew will talk for about 25 minutes, and we will have about 5 minutes for questions, and then we will move to Kathleen's group. Marco and Matthew are going to talk about a very exciting program. This is the first BSc undergraduate in computing science developed under the TRAC-C program. For those of you who don't know what TRAC-C is, it's a new model that University of Worldwide introduced in 2015. It's a different way of more online learning introduced to our distance learning programs. And this is the first undergraduate BSc computing, but the most exciting part of this is also joined with Coursera. So it will be a first undergraduate degree offered by Coursera as well. And Marco has been working on MOOCs for a long time.
But both of us,
both
since
Marco and
the
I
first.
have been working on MOOCs. So their biographies are on the website. Just a word, Marco is a reading, computing and academic director at Goldsmith. Marco's research interests mostly our virtual reality and human-centered machine learning. And Matthew is the program director for this new BSc Computer Science online degree offered by University of Worldwide and Coursera. And they have both, as I said, both been working on books. Thank you.
Excellent. Thank you very much. So let's get going, see if I can convince this to work. Seems to be a quick time.
Okay, for that.
Yeah. Okay, so I'm Matthew Yee King. So I'm, as just mentioned, I'm the Programme Director for the new BSc Computer Science. And with me, Marco, he can introduce himself. So we're going to do a kind of double act to keep it sort of interesting, so you don't just have to listen to me. Marco's going to join in too. And what we're going to talk about is really to sort of lay out the opportunities which we think the computer science BSc provides in terms of research and also improving teaching being our main aim really. So we'll lay that out in a set of themes. So we're going to go through each theme and tell you a little bit about what we see that theme as being. And these are sort of interesting themes that are emerging in current trends in education technology and also in computing technology as well. And then show you what your research opportunities are in each of those themes and give you some examples of work we're already doing within those themes. And then really just encourage anyone who's interested to kind of talk to us or get involved in any of that work to just come talk to us later. So we're going to sort of put out some questions, research questions, which we think are interesting to you, so you can really sort of start thinking whether you might be interested in talking to us about that. Okay. So just a bit of history, and as we just mentioned, so we've been working on MOOCs for a while. So we released the first University of London MOOC in the sort of heady days of 2013, when just after the 2012 year of the MOOC, when everyone was getting all excited or worried, depending which camp you're in, about MOOCs. And our very first MOOC, which I worked on with Marco, you can see us in the picture on the sofa there, with our colleague and friend Mick Grierson. We all developed this MOOC, and we had about 100,000 people who enrolled on this, which was really very frightening at the time, but quite enjoyable and quite exciting, having all these students just kind of milling through that degree, and just seeing more students than we would ever see in our teaching career normally. So that was super exciting. But we carried on. We then we did a specialisation, which was a set of MOOCs all joined together, and that was the kind of next level up. that's still running, as is the original MOOC actually. And then finally, sort of, well, I guess last year, we started work in earnest on the next level of this, which is a complete degree program. So, just some ideas about the degree structure. So we've tried to create a really innovative degree structure where we are looking at what people want to know about in computing, what are the kind of exciting and engaging aspects of computing, and really trying to kind of lay out pathways through the degree that match those. So you can see up there we've got things like machine learning and AI, web development, mobile development, and virtual reality and games. So we've tried to identify things which we have expertise in at Goldsmiths, so that we have academic expertise in these areas, but also we think people are super interested in learning about. Okay, so that's the opportunity. There's the degree. That's our pathway to get to this point. Yeah, another opportunity is this sort of emerging science of learning. So I'm a great fan of this book. It's got lots of nice papers about different aspects of learning and how to optimize learning, especially applicable in the classroom, but also in a distance learning context. And so it's about bringing together. Let me chuck all the things up. It's about bringing together all the sort of new information from neuroscience and also psychology and education, pedagogy, sort of trying to mash it all together and come up with really practical things you can do in the classroom to improve your teaching or online. And so definitely things about when to present a student with difficulty, when to challenge them, what frequency with which you should be testing them for optimal kind of storage, if you like, of that, and recall, if you can use those terms. Sorry, I'm a computer scientist. And finally, just this idea of maybe connecting new information into previously known information. Right. So in terms of the research opportunity, so we think that these kind of online degrees provide the opportunity to use all kinds of research techniques. So it's not just data. It's not just about getting big data and finding statistical patterns in it or whatever. Yes, you can do that. So I've got some gratuitous kind of plots of data there to show that, and a gratuitous, here's how popular my course is, graph at the top there. But on the left there, you see what we've kind of got an ontological description of what you can do on a learning platform. So we tried to sort of develop that with a teacher and with an ontology expert. So we're working in a kind of qualitative, also formal way. So looking at different approaches to this. And then also we're very interested in the idea of participatory design. So if you're creating some sort of learning experience, how do you make sure that it works for the people that are experiencing it? So some of the sort of bits and bobs we're going to show you later have come out of this, and these kind of processes, and yeah. So that's just really the range of types of research we think we can be doing. Yeah, just because it's very important. We've got to just mention, we're aware of that we can't just say, okay, let's just put the rats in a maze and see what they do, right? That's really not what you should be doing in education research, even though it might be tempting when you've got all these kind of online students and everything else. So we're really keen to make sure that our research is designed deliberately to benefit students. So when we bring in tools and things from research projects and use them to support the learning, that it really does enhance the experience that students have. That's our first aim. And secondly, we want to know why it enhanced it. We want to evaluate it and really understand why what we're doing is benefiting the students. So, I mean, what is interesting, so you can do A/B testing in MOOCs, so you can try out different models, but we always try and present students with two good models, not like a deliberately weak kind of teaching model and the good one. Say, look, the good one's really good. We don't want to do that. We want to, always try and do best in class kind of comparisons, and so we've done that in previous studies, and it works, and it's a good model.
So can I just ask that
Yeah.
whilst we're on that slide?
Yes.
Just at the top bullet point, are you going to say that different ethical standards apply for students because they're not paying and they're not investing as much and they don't really know much about them?
Yeah, so so it's not so much an ethical standard, but more that A/B testing, as I said, my idea of a good A/B test is that you get the best in class of two things, and then you compare those. But the problem is with a degree student, you might have the problem of disadvantaging them possibly, or exposing yourself to the risk that you've given a student a different experience from another one, and therefore they're both being assessed with the same thing, and maybe that's a risk, and that's really what that's about.
Right, because it's a different business model, so maybe.
I would
No,
say
it's a quality. It's a quality.
I would
issue.
say it's also because it's about awarding a degree, and I think the level. I mean, yes, you do get a certificate from a MOOC, but that's less of a big thing than doing a research study which may impact somebody's degree classification. That would be how I see it.
No, thanks. That's a really good point. Okay. Yeah. High standards of data management. So put that one up. So yeah. So that's another thing. You know, obviously respecting all appropriate guidelines and best practices for storing data and managing data. Okay. I'm going to hand over to Marco now.
Okay, so we're going to look at five key educational themes. If you come to the digital educator talk this afternoon, you'll see me doing quite a similar slide. It's inspired by our work on the digital educator project, but the themes are a little bit different because they're adapted to the particular degree. The first is flexible learning, so the online content allows many very different ways of approaching learning. Connected learners, social learning is very important in the classroom and increasingly online. We're going to talk about interactive experiences, AI and particularly its application of machine learning and data analytics, and we're going to throw in some of my own research on virtual reality, which isn't in the BSc Computer Science, but sort of just as an interest in future directions. So let's start with flexible learning. So what the online materials really allow students to do is learn in their own time. They don't have to come to a classroom at 10 a.m. on a Friday to listen to the lectures. They can be very flexible because it's primarily driven by video that you can access anywhere in short chunks. So we have 6-minute videos that apply to individual concepts. Video is the resource, but it isn't just video. I mean, there's a lot of interactive learning, particularly quizzes. So we have a lot of interplay between you watch a video and then you test, as we've said, going back to some of the science of learning. Video is a way of getting concepts over. It's important, but on its own, it's not going to give you very deep learning, whereas the ability to test that learning straight after is valuable. Quizzes don't work necessarily for all domains, but I think in computing they work quite well. For each of these themes, we're going to give an example of some of the research we've been doing, so I should have put a credit to this. This is our colleague Rebecca Feebrink, who's done a very cutting-edge MOOC on machine learning. For those of you who are not computer scientists, machine learning is a very sort of popular, quite cutting-edge AI technique that essentially uses data to learn complex concepts that couldn't be explicitly programmed. But it's considered a very advanced technique that you typically have in the third year or master's level computer science courses. She's taking these techniques and teaching them to people without a computer science background, people from artistic backgrounds. I'll talk later how on the BSc we're using similar teaching methods to apply this technique to people in first year of computer science. And she's used a lot of quite innovative video material and sort of animation material, and she's looked at how the use of data from these projects has helped to understand how novices learn machine learning, and she's also applied the same materials back on campus to give a flipped learning experience to our campus students. So there's loads of research questions in all of these things, but a couple of them here are, will this kind of flexible learning attract a more diverse cohort? Who are they? Does it support them well, particularly older students who are in work who have caring responsibilities? And how does this kind of online video interactive way of learning work on campus? We're doing a lot of work on this at Goldsmiths itself, but this degree will also go to teaching centres, and we're particularly interested in how this works in teaching centres, and that's one of the things we'd like to collaborate with CDE fellows on. Okay, switch, we're going to do one theme each.
Okay. So next theme is connected learners. So really it's about understanding what the opportunities are when you're dealing with people who are online and have access to ways of collaborating online and interacting, which perhaps weren't available before, but also the challenge of making it actually work. So on campus, it's quite easy. We can get some students in a physical lab space, and they work on projects together, and great stuff happens. You know, in my lab on Tuesday, I see students, you know, enthusiastically helping each other and all this stuff, and we really want to try and recreate that. That's one of the key things here, because we really think a lot of learning goes on, especially, you know, that peer-to-peer learning, where, I mean, I can't just say, oh, that's stupid, you're wrong, you know, but I hear they say that to each other, and, well, you know, in a kind of, but it's acceptable when it's a peer to kind of have that more direct way of interacting, and that really the person who's training their peer, if you like, is kind of learning how to better kind of communicate as well. That example is quite interesting. One of the things we think is quite challenging is the idea of feedback, and how people give each other feedback, how you learn to kind of help your peers and work with them to sort of support their learning. So yeah, I think there's Connected Learner is a simple thing, but I think around that there's a whole set of really interesting and very challenging things that, to look at. So yeah, so an example of some research we've done. So this is a screenshot of a social learning system that we built in a research project called PRAISE, which is an EU-funded research project. And this was for people learning music, actually. We ended up using it for people doing film studies, people practicing presentations, all kinds of stuff. It's basically a time-based kind of annotation platform, so you can see each of those different coloured sets of blocks is a different person's opinion about that recording, where they can place comments along the timeline. And it was really about exploring what kind of technology people need to do this. So this was built through a participatory design process for teachers and students, so it had all the stuff in that they needed to do. It wasn't just taking an off-the-shelf product. And yeah, so that's one, as you saw earlier on the slide, had this participatory design methodology. That's what we use for this. Okay, the Connected Learner. Research opportunities are, you know, can we create an authentic shared experience online? So that experience I just described in the lab of peer-to-peer learning and you know, excited discussion around learning. How do we recreate that online? That's really challenging. What kind of networks do learners form? So, you know, investigating with a, you know, long-term learning thing like a degree. So compared to the MOOC studies, you know, where you've got 4 weeks or 6 weeks, this is a 3-year thing or even a 6-year thing. So it's really interesting to see how people maintain networks over time in there. And also, you know, more sort of grassrootsy, what kind of group activities actually work? How do you deal with the fact that people are in different time zones and, you know, geographically in different locations and everything else? So yeah, so there's lots of challenges and questions around the Connected Learner. So.
Okay, so the next theme is interactivity in games. So this is using the fact that if students are learning online, they're learning on a computer, and we can use the full interactive potential of a computer. So we're creating complex interactive simulations that foster student engagement through active learning. And we'll talk about gamification. I'll skip to some of these slides. So we've developed a whole range of interactive materials, and I'm going to sit down for this one because we're going to do a very rapid demo. So
a huge personal risk.
Yes, never do a live demo. That's the first rule of. So this is. I've been talking to you about machine learning. So machine learning is a technique where you learn from examples. It's considered very advanced. You only really do it, you know, third-year undergraduate and possibly master's level. We're doing it first term, first year of undergraduate, and we're using built a tool like this. Now I have what you can see here is my video. So we're going to classify it's going to take images of from the camera of this computer and classify whether it's me, whether it's Matthew, or whether it's nobody. So I'm going to first enter my name. So this, what it's going to do is it's going to learn what a picture of me looks like. So I'm going to sort of add some photos. So add a few more. So I can't actually see that screen at the moment, so this is a little bit difficult. Then I'm going to enter Matthew. and if he sits in front, I can see the screen. And I can add lots of photos of him. So rather than... So essentially what this is doing is that rather than trying to explicitly write a program to recognize the difference between us, which would be very hard. I mean, what do you, how do you explicitly say, from the pixels of an image, either of us look like? But it can use advanced statistical algorithms for this data to learn this. So there we go. And if I classify, if you sit in front of it, it should come up and say it's Matthew. So, and will it say it's me? Okay, and it says it's me. So what this is doing is it's a very practical way of teaching students. Actually, I'll switch slides. It's a practical way of teaching students this quite advanced technique in an easy way and getting the practice of doing machine learning. So this is an example how interactive software can help learning and give people a lot of practice in quite a fun way. Even more fun is gamification. And so Matthew's going to bring out a slide in a minute of a tool called Sleuth, which is a game it's a film noir sort of detective style game based on where you have to solve puzzles, solve crimes by writing computer programs. And as students write these computer programs, they unlock clues, they progress through this game, and it's very motivating to put it mildly. So it's basically got completely out of control. We thought sort of students will try, to get to like 70%, they'll kind of do each puzzle hopefully 1 or 2 times, and then move on, and hopefully they'll do about half. We average on campus we average 300 submissions per student in 1 semester. So, and this is we're trying to convince them to do less work on this because they're killing themselves on this project. But it's motivating, it's enjoyable. We're also doing research in this area, so we didn't develop this, but SimCity is a very popular game you've probably heard of. My PhD students, Sarah Sleeman, is looking at how we can use games like this to foster deep interactive learning of mathematics. So looking at sort of motivational factors particularly. So how can this bring better feeling about mathematics in this case, or computer science? And some of the questions, can these tools improve self-efficacy, people's sense of ability to do stuff? How does the design of the game affect learning and progression? Are they just fun, or do these interactive simulations actually improve learning? And the specific question I showed you, can a beginner learn an advanced technique like machine learning using these tools?
Right, good. That's probably the best bit. So moving on. So another trend, learning analytics, AI. Learning analytics are great for looking at how students flow through your content. So, and especially the Coursera platform, they have I think 32 million learners or something, and they're just flowing through these courses all the time. So they've developed some really quite sophisticated tools for evaluating, and examining the flow of students through courses. When do they sort of drop off? When do they engage? And how can so you can really identify which bits of your course are successful and which bits aren't, and modify those. And but the problem is, and one thing we're looking at, and some of my research relates to this, is the problem of sort of having an instrument that we can use to measure all this stuff. So we're used to using graphs and everything else. So what I've been trying to do, and worked on what was then HEFGE funded project last year to develop a new sort of instrument to really to collect information and to look at that information. So, this is it's not a presentation about this, which it could be, but it's a model of the activity of someone who's learning how to code, and it connects to the gamification thing. So if we know how people code, so when we give them different types of lessons, how quickly do their programs change over time during the lesson. So even zooming in to a particular lesson, we can say, okay, in this 2-hour lesson, you know, the rate of change of people's programs was this. So there's no instrument to do that yet. So that's what we're developing here, really to look at in great detail at how successful our programming lessons are or are not, with kind of reliable metrics. So that's an area of research which I'm working on. So what are the kind of opportunities or questions? You know, can we use this student model to better understand the success of lessons? So going beyond just, you know, yes or no, did they finish the lesson or whatever, but really looking in detail at what's going on. You know, what kind of more higher level stuff can we deal with dropout rates? You know, can we do early interventions to help students who look like they're on a kind of learning pattern that isn't going to be a successful one? You know, can we improve our courses by looking at the flow of students through them and looking at where the difficult points are and where the errors are? And you know, also, can tutors use these analytics when in the time when they have interactions with students? Can they be looking at these analytics to know, okay, this person has these particular difficulties with the material, so I'll just focus on those. So can it improve that as well? So, yeah.
Should we? It's past now. Should we skip V and AR because that's not quite in the BSc anyway?
Okay.
I mean, I'll just say that we have some extra slides about virtual reality, which is kind of one of my research areas. It's not there yet in distance learning, but it's one of the new frontiers. But possibly we're running short of time. So, you know, if you're very keen, I'd rather have a couple of questions. But if you're very keen to find out, just ask the question. Tell us more about virtual reality, and I will. So I'm going to skip ahead to, well, this, which is what we're saying is essentially we're keen to collaborate on this with CDE fellows and others. If you're interested in getting involved in this research, please come and talk to us later. And then, should we have any questions from the audience? And then we'll have an opportunity for longer discussion after the second talk, won't we?
Yes.
Just first of all, the undergraduate has it started yet?
The BSc.
Yeah, the BSc.
Sorry. Students will be on it start the 8th of April. So it's closed for admissions, and in a couple of weeks it'll actually be starting.
So that leads to my next question: is what do you know about the students? How old are they?
Quite a lot.
I want to ask you things.
Like admissions have just closed. I mean, we have quite a lot of data on them. I'm not sure we've crunched that data enough to be able to tell you. I'm not sure we can tell you. So, like, the admissions literally closed on Monday, and not everybody's registered. So, you know, we have data, but I don't think we were completely on top of it yet. They're quite global. I think they're quite a wide range, you know, in most demographic factors. Yeah.
I think you said the teaching centres are supporting schools, is that right?
Yes, teaching centres will be from October, not now.
Does that present a challenge to those teaching centres? If you've got this very rich kind of self-contained learning environment that students are expected to be, what does that leave for the teaching centres to do? How
So the question is, I'll repeat for the video, is it a challenge, are these rich materials a challenge for teaching centres in the sense of what is left for them to teach? Yes, that is a concern teaching centres are having. I think we've done quite a lot of work on campus to bring these materials and enrich them with a sort of on-campus experience. You know, I think there is a lot they can bring to it. I think that's a really important question for us, and it's one of the big research questions we want to do.
Yeah, and I think it's worth saying that we're kind of taking our own medicine. So we're using this material on campus and really exploring what is the best way to use this material. You know, are students happy to watch a video and then turn up and have a more kind of discussion-based seminar, or actually, do they want to watch they want to be given a lecture and then they get given the videos anyway because that's a better resource once the lecture's done because they like lectures. So there's all kinds of questions, and I think that we are doing it ourselves with our students and really kind of carefully examining what goes on there, and we make sure we will provide that sort of best practice that we develop to teaching centres.
What motivational research underpins your approach?
Sorry?
What motivational research underpins your approach? For example, around using gamification, I assume that's a proxy for motivation and engagement. Your data seems to show that it has increased engagement.
I can talk about that. So I know
So the question was, what motivation research underpins this work?
Yeah, so just as an example, I think the gamification work is, so the person that's worked on that is our colleague Simon Catan. I wanted to pop up this slide just to put some other people, so not just us, but he actually studied music, and it's inspired by his kind of experience of sort of music pedagogy, if you like, where it's very focused on, you know, physical practice. You really have to get that kind of physical skill of doing it. And he's really interested in investigating whether that can be applied to coding, because, you know, it's not just like writing an essay, you know, it's very structured the way you write code, and you do have to learn how to do it, and to sort of flow from your ideas into code is similar to playing music in a way. So that's one of the, I mean, that's an example. But,
Yeah, and I think Sawad Sulaiman, my PhD student, is working on this area. I mean, I don't have her research to my fingertips to talk in detail about some limitation, but she is finding that both students have a very different attitude to games and mathematics, and it does support the right kind of games support motivation and a sense of self-efficacy. I think her findings are very much that there are a lot of bad learning games out there that are essentially just quizzes dressed up with points, and they're felt to be very dry, whereas the more interactive simulation games like SimCity are more effective. So it's not automatic. You have to have good games foster motivation.